Actually, I have been trying to lose weight because you guys know about my heart disease and how I've struggled with that. One thing I can do is keep my cholesterol low. I'm sure your moms and dads care about that. And weight loss. Let's assume that I started at 160 pounds and began an exercise program, started dieting. And the first week, at week 1, I lost about 4 pounds. Okay? Week 2, I got lazy, lost only another pound. Realizing that I wasn't working very hard, week 3, I actually got way down, lost a good bit of weight. And then week 4, a couple of pounds. Okay? So I started at 160. By week 4, I was down around 149. Did I lose the exact same amount of weight every week? No, I got 154 here, 153 here, 150 here, and 149. Let's just say I'm making numbers up, okay? I did not. This is not a linear function where I can add or multiply by the same amount and get the same type of line. Stay with me, Michael. However, I can approximate what is called a best fitting line to kind of average out what's going on, and it would be right about here. Okay? It would be right about there, that little pink line that I drew. Okay? That is what is called a best fitting line. It doesn't connect the dots perfectly, but it does approximate the best fitting line. Their example is a bit more complex. They talk about how women are increasing as doctors. I highly recommend, ladies and gentlemen, that you girls get into science and math. It's awesome. Physicians in America. Initially, there were 110,000 physicians. A year later, we were up to 117. Second year, 125,000. You guys see how I'm reading this chart across? And so on and so forth. Approximate the equation of the best fitting line for the data. Then predict the number of female physicians in 05. This is a little more complex, but I guarantee you can do it. So I'm not going to rewrite all the data. It's right there for you. But A says equation. This is an approximate, isn't it? Because it doesn't change by the same amount every time. Folks, if you're not paying attention, this is going to be hard. But I can get a y-intercept, can't I? Is there a y-intercept there that you can see? 110. Awesome. Because that first point has a 0 as the x value. Can I find a slope? Sure I can. I can take 0 and 110 and 1 and 117 and use it to perhaps find a slope. Okay? Now they chose some different points. Okay, they chose 7 and 177, and they chose 0 and 108. Okay? What they did is they chose points that they felt were closest on the line. Alright? I just chose points that they gave me. Either way, you're going to come up with something kind of similar. But if I use these, I'm going to end up with a slope of 7 over 1. If I use points that I can see that I created with my best fitting line, like what they did, say 7 and 177 compared to 0 and 108, you can see that the division results in 69 over 7, which is approximately 9.86. A little bit different, okay? Using the line and not the points will approximate the equation of the line that you created. Okay? So this method is going to be closer to the equation for the line. This is only close to the equation for the line formed by these 2 points. And if you only look at these 2 points, the line will be shallower than the best fitting line you had. Okay? So use 2 points that are on the line that you created. Okay? I just wanted you to see the difference. So an approximate equation for the line I created doesn't use B, it uses 108 for B. It doesn't use 110, the points, it uses the line's 0, which was 108. Okay? So your equation is going to be y equals 9.86x plus 108. Now I just want to show you, going back a little bit to what I had initially, when I was trying to illustrate for you. I don't know if I can do this. Yeah. Okay, so remember how I used 0, 110, which is right here, and 117, which is right here. If I used only those 2 points, this is the line I would have. A little bit different, isn't it? Okay, that's why when you draw a best fitting line through the trend, okay, sticking with the trend, which is this, you're going to get a more accurate representation for how the line is moving, okay? Use the best fitting line when you're approximating an equation. As a result, we were able to figure out the line, which is 9.86x plus 108. Okay, y equals 9.86x plus 108. Now, they asked us how many physicians will there be in 2005. That's 13 years later, isn't it? We started in 92. To get to 2005, we got to add 13 years, which means 9.86 times 13 added to 108 will give me my value, which is going to be approximately 236 in 1,000 of female physicians. Okay, that's what this does for us. All right, I want to go over the oral exercises with you guys. Yes, ma'am. Go ahead, Haley.
How did you get the 108?
108, right here. Remember how I told you to take the points from the best fitting line, not from the dots? Well, they used the best fitting line and they figured out that this point right here is just a skosh below the 110, so they called it 108. Okay? That's why it's important that you recognize you're using the points from the best fitting line to make the equation of the best fitting line. Okay? All right. Let's go over to guided practice. Jalen, go to the office. Go to the office. You're not going to sleep in my class. I'll see you in the hall. Go ahead. Okay. Have a seat right outside on that bench. Skill check. Start with number 3. Write an equation of the line through the given points. 0, 8, and 1, 9. You guys see that? We want an M value, and we want a B value. Do we have an M, or do we have a B value?
1.
How is it 1? B value is your y-intercept. 8. Where x is 0, the y value is your y-intercept. Okay? Where x is 0, the y value is your y-intercept. To find slope, I'm going to do 9 minus 8, which is 1 over 1 minus 0, which is 1. Remember, it's change in the y on the top over change in x on the bottom. Okay? 1 over 1, so your slope is going to be 1. Y equals 1x plus 8 is your equation. Okay? Number 4, fundamentally the same thing. I want to go to number 5 though. 5 is 0, -5, and 3, -3. I want an M and I want a B. Do I have a y-intercept? Where x is 0, the other number is it. So what is it? Bravo. I'm going to go, it doesn't really matter. Y is on the top, -5 minus -3 over 0 minus 3. The resulting numerator is going to be a -2. The resulting denominator is a -3, which is 2/3 positive. Okay? Watch your signs. Okay? Subtracting a negative. It doesn't mean -5 minus 3. It's -5 minus a -3. Okay? So your slope is 2/3. Y equals 2/3 x minus 5. Okay? Number 6. Perpendicular. Okay, I'm going to flip my page real quick. Y equals 2x minus 11. And they want a perpendicular line that has a y-intercept of -7. Where x is 0, that's the y-intercept. So, y equals, what's my new y-intercept? -7. Now the question is, what will my slope be? Bravo, Haley. Opposite reciprocal. She is correct. Quicker than quick. All right. Let's talk about clams, shall we? Butter clams. All right. Let's do clams. Everybody with me? You're going to need it for number 26. This shows the dimensions of 7 butter clams. I hate it when they list it from right to left. I just prefer it up and down. So x is the width, y is the length. So the first guy is 13, 17. The second guy is 21, 28. The third guy is 30, 40. The fourth guy is 39, 52. 50, 62. I just like looking at this way. If you don't, it's okay. 60, 77, and 71, 91. Okay? So there's the points that I am going to have to make a scatter plot of. Okay, width is my x value, and it goes all the way up to the 70s. Okay? X is width. And that goes that way. Y goes up to 91. Okay, Y, which is length. Guess I can do tens, right? It doesn't have to be perfect. So 10 to 70, 10, 20, 30, 40, 50, 60, 70. So 30, 60. Up, down, I need to get up to 91, so I'll go by tens as well. 10, 20, 30, 40, 50, 60, 70, 80, maybe 90 is as high as I can go. So 10, 40, I'm just labeling a few of them, okay? So, making a scatter plot, the first guy is 13, 17. Over 13, up 17. The second guy is 21, 28. 21, 28. The third guy is 30, 40. Using graph paper to look a lot better. The fourth guy is 39, 52. 50, 62, 40, 50. Up here. 60, 77, 60, 77, and 71, 91, 71, 91, okay? Definitely does not form a pretty, pretty line, but we can use it, okay? I'm going to approximate to the best of my abilities based on the pattern I see occurring. Okay, this to me is my best fitting line. All right, because it's not on graph paper, it's not perfect, but I would estimate that if I compare points, my y-intercept is at 0, 2. That's what I think. And 30, trying to find some other points that fit. 30, 40, 30, 40 is kind of right on the line. How about this one right here? What was after 30, 40? 39, 52 appears to be on my line. 39, 52 appears to be right on my line. Okay, so I extrapolated to find my y-intercept. 39, 52 is the other point. Okay? These 2 points are the points I'm going to use for my best fitting line equation. Okay? Y equals some kind of x plus y-intercept 2. And slope, 52 minus 2 over 39. So 50 over 39. Shoot. 50 divided by 39. 1.28. Okay. So your equation is y equals 1.28x plus 2. Now I just want you to know the book answer is y equals 1.26x plus 1.4. Pretty similar, aren't they? I drew my graph, I approximated my line, I came up with this. I will not mark you wrong for having this versus that, okay? This is getting the gist of the slope and getting the gist of the y-intercept. To be off by 6/10 in the y-intercept is nothing. Okay, so I just wanted you to be aware of that.
Was my graph
Never. Just do the best you can.